Just another moment, I'll let you know. Just another moment, I'll let you know. Okay, go ahead.
Thank you, Dina. Good evening. This month is Women's History Month. The contribution of women through the years have often gone unappreciated and forgotten. But each year in March, Women's History Month is a time for reflection, appreciation, and celebration. Women's History Month is an important time to recognize contributions, both large and small, that have changed our lives for the better. So as Denver Astronomical Society, we want to celebrate the Women's History Month with a talk about women in space and astronomy. So for that purpose, we have a special guest speaker, Sabrina De Soto. Sabrina is a third-year PhD student of physics and astronomy at University of Denver. Her research is on determining the structure of stellar explosions known as supernovae. Growing up in Colorado, she first became fascinated with space camping at the Great Sand Dunes National Park, where she would hike up the dunes with her mother, where she would gaze at the stars all night. Her interest in physics followed shortly after in high school, where she had an enthusiastic teacher who showed her the joy of explaining everyday phenomena. Combining these two interests, she pursued her undergrad degree at Queen's University in British Columbia, Canada, where she got the first taste of astrophysics research in radio astronomy. Eager to build upon her research skills, she accepted a National Science Foundation sponsored internship at Lehigh University in Pennsylvania, where she studied spin rates of variable stars. She is now back at home in Denver, pursuing her PhD at University of Denver, as well as continuing to explore the cosmos from her own backyard. So please, Sabrina, proceed with your presentation.
Great. Thank you for that introduction, Dr. Ansoy. And thank you all for having me here for this talk. So as we said, it's the month to celebrate women and what they've accomplished, and for all the work that women have contributed to our understanding of space. It's about time we recognize their successes and the hurdles that they had to overcome to get them. Being a female and a space enthusiast myself, I'm so very excited to share a few of these triumphs with you all today. Let's start with a few of these hurdles first. So, according to the United States Census Bureau, only 8% of the STEM workforce were women in the 1970s, and 3% of engineers. After half a century, this has now increased to only 27% of the STEM workforce in 2019, and 15% of professional engineers being women. The American Institute of Physics concluded that women earn only 33% of astronomy degrees, 22% of engineering degrees, 21% of physics bachelor degrees, and 18% of computer science bachelor degrees. As of 2021, 596 people have been sent to space, of which only 8.2% were women. So that's 72 women out of the 596. So while opportunities for women are growing, it's clearly the effects of a patriarchal society are not so easy to mend. And these are just a few of these statistics. Effects beyond the numbers include harassment in the workplace, a lack of trust between employees, and an epidemic of imposter syndrome among women. Oops, sorry. Didn't know it would scroll so fast. So now I know that's kind of starting the talk off a little heavy, but that's just the reality of what things are. And it was in this reality that the pioneering women, like the ones I'm going to share with you today, triumphed in the face of. So now I'm briefly going to introduce a few of these pioneering women, starting with those that were in astronomy research. First up, we have, oops, let me get a laser pointer going. Here we go. First up, we have Dr. Vera Rubin. Dr. Rubin is known as the mother of dark matter for seeing that the spin rates of galaxies did not make sense for the visible matter in them. She was not accepted into Princeton for graduate school because of her gender, but she did go to Georgetown and earned a PhD in 1954. It wasn't until 1963 that Princeton allowed a woman to earn a PhD there. Next up, we have Annie Jump Cannon. Annie was the valedictorian at Wellesley College. She earned a master's from there and then later took graduate level classes at Radcliffe College, Harvard, but was never allowed to earn a PhD there. She kept on her path of astronomy and did research for Dr. Edward Pickering to classify stars. And Edward said about her work, "Miss Cannon is the only person in the world, man or woman, who can do this work so quickly." Henrietta Leavitt is known for what is called the period luminosity relationship of variable stars. She didn't get to take astronomy classes until her 4th year of college, and then later took graduate level classes, but never earned a graduate degree. She made her discovery working as a computer at Radcliffe College. And although we know Edwin Hubble for his work discovering that the universe is expanding, it is often overlooked what a crucial role Henrietta played in finding this. Down here we have Maria Mitchell. She discovered a comet in 1847. She was actually given a gold medal prize for this by the King of Denmark, even though she is American. She worked as a librarian, an educator, and her father was the one that taught her how to operate telescopes. So she was always fascinated with space. She had no college education, but the founder of Vassar College recognized her brilliance and gave her a job as a professor there in 1865. And finally, we have Jocelyn Bell, who is from Northern Ireland. Jocelyn is known for making a Nobel Prize winning discovery of radio pulsars as a postdoc. However, her advisor, Dr. Hewish, was the one given the Nobel Prize for this. Bell said at the time that this was just because of her position as a student and not because she was a woman. Next up, we have a few of those 72 women astronauts that have contributed to firsthand exploration of space, starting with Sally Ride, who was, of course, the first woman put into space in 1983. She actually dropped out of college briefly with goals of becoming a professional tennis player after winning a championship in women's singles, but she returned to college and earned 2 degrees, both in physics and in English. Next to her is Dr. Ellen Ochoa. Dr. Ochoa became the first Hispanic woman in space in 1993. She later became the first Hispanic director of the Johnson Space Center, and neither of her parents had higher degrees of education, and Dr. Ochoa is from Los Angeles. Here we have Dr. Eileen Collins. She was the first female commander of a US spacecraft, a mission to deploy the Chandra X observatory that now takes data. She earned an honorary PhD from Elmira College and from Webster University. And then we have the first woman ever put into space, a Soviet cosmonaut by the name of Valentina Trashkova. And she was originally a textile worker, but loved flying and trained in secret to be a competitive parachutist before becoming an astronaut. Finally, we have Dr. Jessica Watkins, who's actually raised here in Lafayette, Colorado. She's a former American women's national team rugby player, and she will be the first woman to undergo the longest mission at the International Space Station starting April 2022. So we can all look forward to that. The third group of women that I'm going to talk about, I call the support team. A few of these women are Nancy Roman. She was the first female executive at NASA. She created NASA's Space and Astronomy program and became the first chief of astronomy. There is a Nancy Roman X-ray space telescope that is currently in construction and is set to launch in 2027. We have Dorothy Vaughan, who was the head of the segregated computing unit at NASA, a team of amazingly brilliant women who for the majority of time were unacknowledged for their crucial work to getting us to the moon, until the release of the movie Hidden Figures in 2016. On her team was Miss Mary Jackson. Mary was one of the computers and later became NASA's first Black engineer. And again, this is not an extensive list here of amazing women in the field or the amazing women on even this particular team at NASA. For that, I highly suggest seeing that movie. So for the sake of time, I got to pick a few of these women to go into a little more detail on. And so for each of the categories, here are the ones that we're gonna dive into tonight. Starting with Dr. Cecilia Payne Gaboshkin. Cecilia was the first woman to earn a PhD from Radcliffe College. So I'll give you a little quick background on Radcliffe College. As I said, she was the first woman to earn a PhD there. However, she did follow the suit of many great women working in astronomy. So in the 1800s, Harvard did not accept any women to the program or give them any status at all. Women could work there as cooks, cleaners, librarians, and administrators only. However, women like Hannah Winthrop were constantly contributing to their husband's work for no credit at all. And Hannah is now recognized for helping her husband make his observations of Mercury and Venus. So finally, a woman named Elizabeth Agassiz founded the Society for Collegiate Instruction of Women, known colloquially as the Harvard Annex, that later became Radcliffe College. And it wasn't until World War II that Harvard officially accepted women into their primary school. So, Dr. Payne's work, she's best known for the thesis that she wrote on the composition of stars. She was the first one to draw a connection between the spectral class of stars and their temperatures. Her work showed that features we see in the star's spectrum are related to their ionization temperatures, are related to the ionization temperatures of elements, and that this connection can be used to calculate the abundance of elements in stars. From this, she concluded that the sun is primarily made of hydrogen and helium, a fact that we in the field learned today in day one of class, but that many at the time did not believe to be the case. Before her work, astronomers believed that the sun's makeup was similar to that of the crust of the Earth, and because many stars exhibit the same spectra, they thus believed the elemental makeup of the universe was similar to the crust of the Earth. So some really applauded this work of hers, including an astronomer by the name of Otto Struve, who called her dissertation the most brilliant thesis ever written in astronomy. But others, of course, were skeptical of her work. And perhaps it was because they just contradicted their own work and the beliefs at the time, or perhaps it was because she was a woman that produced the work. It was probably some combination of the two that made one scientist, Dr. Henry Russell, dissuade her from publishing her work outside of her thesis. However, Henry later came to the same conclusions himself and published the work himself. So he was the first one credited for that work. He did give a mention to her in that paper, saying that his conclusions concurred with that previously done by Dr. Payne. Now, despite not publishing her own groundbreaking discovery, Cecilia went on to triumph. She became the first woman to earn a full PhD, a full professorship in arts and sciences at Harvard, and the first female head of the department there. And this photo at the bottom here is some of the women of Radcliffe College. This fifth one from the left right here is actually Annie Jump Cannon. And this one right here is Cecilia Payne. The next woman I want to recognize was the first Indian American astronaut, Dr. Kalpana Chawla. Kalpana was born in present-day Haryana, India. Her parents moved to that region after the partition of India, and otherwise would have lived in what is now Pakistan. So that is very fortunate for Kalpana, because in Pakistan, women did not get the right to education until 1976. And in the 1980s, when Kalpana was in college, only 25% of women were educated compared to 41% in India. A fun fact about Kalpana is that she actually didn't have the name Kalpana until she had attended grade school. And then she gave that name to herself, which means idea or imagination. So Kalpana earned her bachelor's degree in aerospace engineering from Punjab Engineering College in India. And then she moved to the United States and earned her PhD in aerospace engineering from CU Boulder. She then went on to work at NASA in 1988. She held certified flight instructor ratings for airplanes and gliders and commercial pilot license for single and multi-engine airplanes, as well as seaplanes. As soon as she became a naturalized citizen of the United States, she applied to become an astronaut and was selected for her first flight in 1997. On this flight, she logged 15 days and 16 hours in space and was responsible for deploying the Spartan satellite. However, the Spartan satellite malfunctioned, and so they had to do a rescue of it, and she underwent 5 months of investigation where they finally determined that it was indeed faulty software, as she had said, and it was not her fault. She then worked at the office of NASA for the next 4 years and was finally chosen for her second mission in 2001. In 2003, she returned to space aboard the Space Shuttle Columbia. However, upon the reentry to Earth, a piece of the insulation that had broken off during launch allowed intense atmospheric heat to compromise the internal wing structure and ultimately led to the entire shuttle breaking apart and killing all the crew members aboard. So those crew members were deemed national heroes, and Dr. Chawla has institutions, spacecrafts, and streets named after her. Katherine Johnson is the next woman I would like to talk about. She is also one from that movie Hidden Figures. A little bit more about her. She was born in as Creola Katherine Coleman on August 26th in 1918 in White Sulphur Springs, West Virginia. She showed strong mathematical abilities from an early age, but because the county that her family lived in did not offer public schooling for African-American students past the 8th grade, her parents arranged to have her attend a high school that is the Institute of West Virginia, where the school was actually on the campus of West Virginia State College. So there, Katherine excelled. She was only 10 years old when she enrolled at that secondary school, and then attended West Virginia State College, a historically Black school, and earned her bachelor's in math and French at the age of 18. She later attended graduate school as one of the 3 African-American students and the only Black woman admitted to West Virginia University, but dropped out just 1 year into it after becoming pregnant. In 1953, Katherine went to work for the National Advisory Committee for Aeronautics, what is now NASA. She started in a group of all women mathematicians, or computers who wore skirts, as she called them, and was supervised by Dorothy Vaughan. They worked in a segregated office that was labeled colored computers, but because of her exceptional knowledge and analytical analytical geometry, she was one day chosen as one of 2 women to go help an all-male flight research team. She did the trajectory analysis for Alan Shepard's May 1961 mission of Freedom 7, which was the America's first human spaceflight. In 1962, Johnson did the advanced orbital calculations to verify those used by John Glenn's computer in the first orbit around Earth. Because it was the first time astronauts would be using electronic computers systems in as their navigation, most of them did not trust them. So they would like Katherine to be the one to check all of those calculations. So as part of the pre-flight checklist, Glenn asked engineers to have Katherine run through the same equations that had been programmed into the computers, but have her do it by hand on her desktop mechanical calculator machine. And Glenn is quoted saying, "Get the girl. If she says they're good to go, then I'm ready to go." So Katherine continued to do calculations for 33 years at NASA. She was later recognized for her contributions and in the movie Hidden Figures, and more importantly, was awarded the Presidential Medal of Freedom in 2015 and the Congressional Gold Medal in 2019. She passed away in 2020, but she will hopefully now be forever remembered for her brilliant work and dedication. She was quoted saying, "You had a mission and you worked on it, and it was important to do your job and to play bridge at lunch." And the final woman that I would like to talk about tonight is Sarah Al-Amiri. Sarah is a 35-year-old United Arab Emirates Minister of the State for Advanced Technology. She was born in the United Arab Emirates. She earned a bachelor's and master's in computer science at the American University of Siraj. She was hired by the United Arab Emirates Space Agency at the age of 22 and appointed the head of the Emirates Science Council in 2016 and the Minister of State for Advanced Scientists in 2017 at the age of 30. And she is now the science lead for the Emirates Mars mission HOPE. So the United Arab Emirates set a mission in 2014 to launch a probe to Mars in 2021 to orbit it and to map the Martian atmosphere over a Martian year, which is 687 Earth days. So despite this incredibly short timeline to get together such a mission for a very, very young space program, the space program actually didn't even exist when Sarah was in school. They had to really be focused on what they did. And so HOPE did have a successful launch and a successful journey to Mars. It has been studying the atmosphere there for over a year. And their probe has discovered a discrete aurora in the Martian sky that they think is caused by the interaction between solar radiation and traces of magnetic material in the crust of the planet. This must be left over from what its magnetic field was, since that magnetic field has long been stripped away. So this mission also has a Colorado connection, interestingly enough. They collaborated with CU Boulder to assemble the probe. And Sarah continues to push the UAE Space Agency forward to new frontiers. Their next mission is set for 2028. It is a probe that will fly by Venus and then 7 asteroids, and it will finally land on that final asteroid. So that is a very complex maneuver for, again, a very young space program to undertake. But Sarah does not seem to be intimidated by it. So one of the things that I admire most about Sarah Al-Amiri's work is how she got it done and the precedents that she set for women in this field in the future. Not only has Sarah achieved all she has so far as just a 35-year-old woman, she's empowered other women around her to do the same. The team of scientists that Sarah directs for the Mars mission HOPE is comprised of 80% women. And she recognized that other women, just like her, had a skill set that was needed to see the UAE Space Agency reach their goal of getting to Mars. She's given many interviews talking about the potential for women in the STEM workforce and what she calls as a leaky pipeline between women interested in STEM and those who actually receive a career in STEM. As shown by her quote here, the first step is to recognize this issue. So she says, it's something that exists and it's something that we need to acknowledge exists. And by acknowledging it, you're able to treat it. Along with this acknowledgement, I think it's also important to recognize the amazing work that women have accomplished and in these disciplines and in the positions that they've held. So with that, I would like to recognize a few of the brilliant women that I work alongside with. The first one is Rachel Johnson. She is my fellow PhD candidate at the University of Denver. She studies massive binary stars, and she introduced me to the secret of enduring late nights of work, which is McFlurries. Next one is Dr. Manisha Shrestha and Jamie Lomax. They're both graduates from our research group. Manisha is currently studying gamma ray bursts as a postdoc in London and just accepted her second postdoc in Arizona. Jamie is an assistant professor at the United States Naval Academy. And on top of teaching and research, she recently became a new mother. And finally is Dr. Jennifer Hoffman, who is my research advisor at DU and is the chair of the Chamberlain Observatory. And I'm not sure if there's an official stat on this, but from my own experience, all of her research teams have been at least 50% women, and she is incredibly supportive in that field. So talking about these examples, both the ones close to us and the ones throughout history, are very important part of providing future generations of girls with role models that they can relate to. And from that, we can begin to normalize this idea that they can succeed in these places. So by celebrating these accomplishments, we can create a culture that reassures more women and young girls that they do belong in STEM and they do belong in space. Thank you very much. And I think we have plenty of time for some questions.
Okay, great. Thank you, Sabrina. Can you tell us a bit of your research?
Absolutely. Would you like me to keep sharing the screen or stop sharing?
Unless you have a chart or anything, yeah, you can stop sharing, I guess.
Okay. I unfortunately did not prepare any charts of my own research. So my research, as we noted, is studying the geometry of supernovae. So I do that using polarized light signatures. And our goal is to look at what elements exploded in what shapes from the supernovae. And by that, we can kind of backtrack what mechanism caused the supernovae to occur in the first place. And we can start relating different types of supernovae together. So there are about 6 different types of supernovae. Again, those are based off of what elemental signatures we see in their spectra. So the type that I look at are type 1b and 1c supernovae. And those are particularly interesting because they have no hydrogen in their spectrum. So this kind of ties into what Dr. Payne Gaboshkin found, which is that hydrogen is the most abundant element in the universe. And we conclude that because of her findings that hydrogen is the most abundant element in the sun and similar stars to the sun, and extrapolating that to other stars in the universe, hydrogen just overwhelmingly outweighs any other material in the known universe. So we often joke as astronomers that hydrogen and helium are the only elements that matter, and the rest of it is just pennies. But so the supernovae that I study are particularly interesting because they don't have any hydrogen signatures in them, which suggests to us that somehow they burn through all of their hydrogen before exploding, and either burn through it or through some wind or binary star interaction, it was swept away so that there's no traces of it left. But interestingly enough, if you watch these things over time, the hydrogen starts to appear again. So that's a bit of a puzzle that we get to dive into on, was it really burned away, or was it just kind of hiding behind something else in our initial observation?
What about heavier metals?
So the heavier metals, now the ones that I look at, there's a lot of iron lines. Helium is, it's not a very heavy metal, but that's the next most common signatures we see. Yeah. And other than that, we see silicon from time to time. Carbon will be in there. Again, anything other than hydrogen and helium, we consider heavy metals in astronomy.
Okay. Are there any questions about the topic of women in space and astronomy, as well as her research, I guess? It is open for questions. Raise your hand if you have a question.
Well, I don't have a question.
Yes, please, Ivan.
I don't have a question, but I've got a couple of names to add to her list.
Please,
In 1962, there were 10 astronomy majors at Indiana University freshman class. And out of 4,500, of the 10, there were 2 girls. The 2 girls went and, 2 of them made their degree in astronomy and went on to make a career out of it. The 2 girls, her names were Catherine Garmity and Roberta Humphreys, who was at the University of Minnesota. So that's my 2 cents worth.
Okay, thank you, Ivan.
You're welcome.
Do I see a question? Anybody?
I have a comment, Mehmet.
Yes, please go ahead, Dina.
One of the things that I learned, my name's Dina, and I'm the DAS president. I'm just hiding this evening. But my background is I'm a retired air traffic controller, and I worked for a time at an airport that had, it was an F-16 training base for the Oregon Air National Guard. And one of the things I learned while I was there is that physiologically speaking, women are actually better suited for things like flying aircraft, because our bodies are better suited for things such as withstanding G forces. And I wondered if you had had any contact with female astronauts and ever had any discussions about things like that with them.
I have not personally met any of these women. I almost thought about reaching out to Dr. Watkins, who is the one from Colorado here, and I still might do that. I did not know that about women as astronauts. That's definitely fascinating. I think it also makes sense too. I went to a talk about just the ergonomics of functioning in space. And, when you have to do these intricate motions in a clumsy spacesuit, so the smaller and the tighter that they can make those spacesuits, the more efficient that they're going to be able to do their work up there. And I think that women might be more fit for that physically too.
Actually, the women had their own spacesuits only recently, if I remember correctly. The first set of women who went to space did not have spacesuits geared for women. Am I correct?
Yeah, that's absolutely correct.
Right.
Yes. And the thing about withstanding the G forces has to do with the way that weight is typically distributed in the bodies of women versus men. That's what makes women better at withstanding the G forces. So that would be a good topic of conversation for you and her. I'd be curious to hear what you found out from her about that.
Definitely. I did, as a kid, of course, want to be an astronaut. I've kind of let that go. I don't think that I personally can withstand those G forces. So
Well,
I'll stick behind my computer.
nobody thinks in the first place, but they get used to it.
Yeah.
Why did you choose your field, Sabrina?
So I first, I chose astronomy in general. Like I said, because I'm really fascinated with space, and it's one of those frontiers in physics where physics is used to describe everyday phenomena, but in space, it's more of a puzzle, and I kind of like that about it. Our laboratory is, billions of light years away from us, or at least in my case, I look at supernovae that are very, very far away. So that kind of adds an added hurdle and an added bit of just kind of creativity that you have to have with how to apply the things that we know here on Earth and what that means for the laws of physics beyond here. So I was really fascinated at the idea of getting to overcome that challenge. It is it is quite hard sometimes, and it makes us question a lot. Why do we know what we know, and how do we? But I keep going back to Dr. Payne's work that she did incredible experiments from chemistry that is true here on Earth, and was able to relate that to stars, again, light years away. So that's how we do it.
You mentioned that 50% of your group is women, but what is the percentage of master's or PhD students in the physics and astronomy in the university are women?
I don't know specifically for DU. I do know actually it kind of flip-flops when you get to the PhD level. Even though women only earn 33% of bachelor's degrees in astronomy, they earn, I think it's like 48% of the PhDs in astronomy. So it does tend to balance out. I guess that's something to say of our fortitude once we've made it past that first hurdle. We really stick to our guns there. Yeah, I don't know specifically at DU. It's definitely not anywhere close to 50-50, just from my experience walking around there.
Why did you choose DU?
I chose DU for a couple of reasons. I traveled a lot, and then it was kind of nice to be able to come home. And also, I really liked the professors that I got to work with. So the idea of working for Dr. Hoffman, I never worked with a female advisor. Even the high school teacher that I had in physics that inspired me was a man. My advisor in undergrad was a man. My advisors on internships were all men. So I met Dr. Hoffman, and my idea of going to grad school was I am fascinated by anything physics, anything in space. I would really love to study all of it. So to me, it was really important to get along with my advisor because I'm going to be here for years. And she provided that support system. as well as another one of the female teachers at DU that is the one, I am her teaching assistant, and I teach her first year labs. It's also just nice to work with women there.
Okay, any questions? Yes, Mark.
Just mainly a comment. You're talking about all of your advisors and everyone being men. Back in 1959, it was a woman that got me interested in astronomy in such a way that it has kept me there and taught me the math skills that I needed as I'm stumbling along and getting started. And if it wasn't for her, who knows what way would be wasting my time in life at this point. So, the women have always been out there. I guess we just have not been able to recognize them as it should be. But I just wanted to throw that in on behalf of my dear Aunt Florence.
Yeah, I totally agree. There's been a lot of women in the field that have done really crucial work for it. And especially too, to point out that, women shouldn't only inspire women. Their work it's science, and it should inspire all scientists and be valid and taken as such.
So what would be your advice, Sabrina, for, let's say, high school students not decided what to do for their university education?
My advice would be to not be overwhelmed by all of the options. I also didn't know what to do when I went to undergrad. I went to a liberal arts and sciences school, which arguably did not set me up to get a PhD in astronomy because I didn't get an undergraduate degree in astronomy. I got a liberal science degree or a liberal arts degree, sorry. So I think going that first transition from high school to undergrad, it's kind of just important to give yourself the space to explore a lot of things. And then if you do find they're interested in a science, to talk to your teachers about it and to ask them, do you have any research opportunities? Because researchers love to talk about what they do, and most of them need help and like to share that experience. And that's a great way to kind of get started and see if research is for you and in what capacity.
Okay. Any other comments? Mark?
I will plug one more thing
Yes.
before we adjourn, if I could. I don't have a slide or anything ready, but I will send you the information because I actually just got the phone call today. So I had proposed to do an astronomy club for one of our local middle schools here. It's the Platt Middle School in Aurora. And so I'm going to be hosting an astronomy club there with two of my PhD peers. And yeah, maybe we can team up with the Denver Astronomy Club or Astronomical Society or something. But
Sure.
shortly we will be plugging for a little bit of starter money to do some of these activities with kids.
Well, contact us when you are ready to take some action. I see, Mark, your hand up. Is this from before?
Can you hear me?
Yes, proceed.
Yeah, I was going to ask, what's this question of the creation of heavier metals? I've heard some talk now about maybe it's not happening in supernovas so much as maybe collisions between neutron stars or other theories. What's the latest thinking about that?
You mean the burning of metals causing the supernova versus versus an impact causing the explosions?
No, I'm just watching like the Science Channel, and there was a thing about how they used to think that the only way gold could be created and some of these really heavier metals was in the explosion of a supernova. But then there's these other theories now about collisions between, I think it was between neutron stars, where it could happen.
Mm-hmm. Yeah, so that is true. That's one reason that we also like to study supernovae and we model them, is to see how these heavier metals could possibly have been created. As far as gold, actually, gold is thought to now, well, actually, it's known to come from gamma ray bursts, which are the second most energetic phenomena in the universe, next to a black hole merger. So it does take, massive amounts of energy to create those. And I think that it is veering away from, we once thought that supernovae were the most energetic phenomena, and now supernovae are here, and we have, black hole mergers, and we have gamma ray bursts, and we have neutron star collisions, and yeah, we're learning more and more about high amounts of energy out there.
Great, thank you.
My final question, Sabrina, is what do you want to do once you graduate? With a PhD, I mean, assuming
yes.
that you graduate with PhD, what are your plans?
It's I'm right in the middle of it, so it's always hard to imagine that day coming. But it will come. And when it does, I would like to stay close to science. I would like to still be able to do some research in some capacity. I am kind of going to test this out with running this club, but I really enjoyed teaching my first year undergraduate class. So I'm not sure that I would necessarily go into a professor program where I only work with physics majors. I kind of like the idea of teaching those that aren't necessarily geared towards physics, but I think there's always something interesting about space for everybody. So my plan right now is to hopefully teach in that capacity, maybe just kind of at a community college level, or maybe just some undergraduate level in that case.
Bill, you have a question?
If Bill doesn't have a question, I'd like to make a comment. Sabrina, I put my email in there. That's president@denverastro.org. I'm really excited about your plans for the middle school. We started a junior astronomers group here that has morphed into something much, much bigger. So if you'll send me your email address, I want to let you know more about that. It's free. It's for students really anywhere in the world. And I'd love to let you know about it, because I think it could be really exciting for those kids to join if they're interested. So
yeah,
and they have a very interesting name.
It's the Cosmic Generation.
They are called Cosmic Generation.
We
Yes, Bill.
presently
I finally
have
managed to get unmuted here, and I wanted to make a plug for one of my favorite women in astronomy. Her name is Dr. Rebecca Smethurst. She's at Oxford University in the UK, and her area of interest is black holes, but she has a weekly or a regular video postings on YouTube under the name Dr. Becky, and she covers all areas of astronomy. She has a real talent for explaining complicated concepts so that average Joes like me can understand them. And her love of astronomy it's obvious and it's infectious. She's just a real bright star in popularizing astronomy. That's Dr. Becky, and you can find her by searching Dr. Becky on YouTube. Thank you.
Thank you, Bill.
Yeah, I didn't even mention the women on the team that did win the Nobel Prize for imaging the black hole.
Yeah, there are actually several more. If you do a search, quite a few women who, I was told that only 15% of professional astronomers are women, but their contribution is far more than 15%. So one thing to say is that the women's contribution in the field of astronomy is much higher than the percentage of individual women in this space. And that stands out as maybe in not just in that field of astronomy, but almost all the fields. So if there is no other question, I would like to thank Sabrina for the presentation. And we very much appreciate Sabrina. And we also wish you well with your work, success for your studies, and hopefully we'll see you again in some other presentations in the future. And we also encourage you to become a member of our Denver Astronomical Society. You can join us as student member, which is only $12.
Sounds great. Thank you guys again for hosting me.
Okay.
And I really
Thank you.
enjoyed hearing your stories about women that inspired you too. That's awesome.
Thank you
very
for
much.
joining us.
Thank you for joining us. Okay. Thank you, Dina, for live streaming it.
My pleasure. Have a good evening, everyone.
Yeah. Have a good night, all of you.
Thank you.
Have a nice weekend, whatever is left. Enjoy the weather.